Algebra 2 students, in this video we will be studying functions. Now, like most opening lessons in a chapter, it is foundational. What we're going to learn today is foundational to the rest of the chapter. I cannot stress that to you enough. Please take really good notes and focus and listen well. Your heading for today is Intro to Functions, and your lesson number is 6.1. Be sure and include today's date also, okay? So, Intro to Functions, lesson 6.1. Be sure and include today's date. Now, let's jump right into this by looking at a definition of function. Copy this in your notes, please. Copy this in your notes. A function is a relationship between numbers, or it could be an equation also, in which each input has exactly one output. Okay? Excuse me. A function is a relationship between numbers, or it can be an equation, okay, in which each input has exactly one output. Please copy that down. Now, I will expound on that definition later during this lesson, and I will explain what that means, what this definition means, a lot better. But for now, I need to go over some interchangeable terms that you need to be very familiar with. Here they are. You need to know these. I'm going to use these terms interchangeably all the time, not only for chapter 6, but for the rest of the school year. So students, here they are. All four of these terms mean the same thing, at least in math class. All four of these terms mean the exact same thing. So if I'm talking about the x value of an equation like this right here, if I told you that x equals 2, and I told you to put 2 in for x is your x value. We could also call this your input. We could also call this number your independent variable. We could also call this number your domain. Are you getting this? If I gave you an equation like this, and I said evaluate this equation at x equals 2, that means you're going to put 2 in for x. So what number did you put in for x? 2. That's your x value. Well, you can call this 2 your input, or you can call it your x value, or your independent variable, or your domain. Now, if you put 2 in like this, 2 times 2 is 4, plus 3 is 7. When you put in 2, you got out what? 7. Well, 7 is your y value. We can also call that your output, which, let me stop there. That makes sense, doesn't it? We put in a number 2, and we got out a number 7. So it makes sense. Input, output. So this value right here, 7, y equals 7, that can be called your output, or it can be called your y value, or it can be called dependent variable, or it can be called your range. Okay? Notice how I've put these terms across from each other, and they're opposite, like they're the antonyms of each other. Input, output, x value, y value, independent variable, dependent variable, domain, range. Okay? So students, you need to know these terms very well. Okay? Understand these. We're going to use them all the time. When I say independent variable, I expect you to know I'm referring to the x value. If I say range, I expect you to know I'm talking about the y value, and etc., etc. All of these words you need to understand. These four go together, and these four go together. Got it? It's very important you understand that. Now, if I give you an ordered pair, we can label these numbers a lot of things. Let me show you. Write this ordered pair down, please. -6, 5. I could call this -6 what? I could call it the x value. I could call it the independent variable. Write all this down, please. I could call it the domain. Or I could call it my input. Okay. This 5, I could call it my y value. Or I could call it my dependent variable. I could call it my range. Or I could call it my output. Okay, now I know I basically just repeated what I said back here, but I want you to really, really get it. Okay, I'm going to move on. Pause the video if you need to. Back it up and listen to it again, or get caught up on your notes. But I can take an ordered pair like this and label this -6. Any of these 4 terms. I can call this 5 right here. Any of these terms. They're all the same, okay? These 4 mean the same thing. These 4 mean the same thing. Now I want you to find the domain and range of a given set of ordered pairs, okay? I want you to find the domain and range of a given set of ordered pairs. So here we go. I would put the letter D for domain and put a colon. And here's your domain. Remember, your domain is your what? Domain is your x value. Got it? So here's your x value, -1/2, comma, here's an x value, 4, comma, here's an x value, 4. Now let's stop. Really, technically, you should not write the same number twice because you're just making a list of numbers. There's no reason for that, okay? However, if you want to, you may. I'm not going to take points off, but technically you shouldn't. Next x value is 0. Next x value is 0. So your x values are -1/2, 4, 4, 0, 0. So there's your domain. Now here's your range. Your y value 0, 3, -3, 1, -1. Remember, in an ordered pair, this is your x value, this is your y. So my range is the same thing as my y value, okay? So my range would be 0, 3, 0, 3, -3, 1, -1, -3, 1, -1. There we go. So you took a list of ordered pairs and you listed out the domain and the range. Really pretty simple, okay? Alright, now try this one on your own. Pause the video, unless you don't want to. If you want to do it with me, that's fine. But if you want to try it on your own, pause the video now. Do it on your own. List out the domain and range, and then play the video and see if you got it right. Okay, here we go. My domain would be 0, 1, -1, -2, 2. And I've seen a lot of books do it like this. 0, ±1, comma, ±2. Since you do have positive -2 and positive -1, that's fine if you want to do it like that. I've also seen a lot of books listed in numerical order. So it'd be -2, then -1, then 0, then 1, then 2. I am totally fine with this right here. Just listing out the x values as they happen going across, okay? I am totally fine with that. Okay, so there's my domain. Alright, now let's list out the range. -1, 2, 0. 5, 9. And there are your y values or your range. Now students, if you watched me do that, hopefully you understood it. For those that tried it on their own, hopefully you got it right. Okay, if you missed it, find your mistake, okay? And then hopefully you're understanding this, alright? So we're simply practicing over and over and over what I taught you right here. You've got your list of input. You've got your list of interchangeable terms here and interchangeable terms here, okay? Alright, moving on. another angle, okay? I want you to sketch a graph from the given mapping diagrams, okay? Now you're probably saying, what's a mapping diagram? I'm going to show you, okay? There's more than one type, but this would be an example of a mapping diagram. Take a look at this. Copy this down, okay? I have like a circle, or it could be a box, whatever, with all of my inputs. Then I have a circle or a box or an ellipse like this with all of my outputs listed. And then I draw arrows showing you this input here gave me this output. This input gave me the same output. This input gave me this output, etc., etc., etc. Okay, so this is called a mapping diagram. Now, I want you to sketch a graph of this, okay? I want you to sketch a graph of this. So, in your notes, go ahead and copy this down since we're going to be dealing with this, okay? Copy this down, please. And then after you've copied it down, if I'm going too fast, just pause the video, okay? You know what, guys? I'm going to change this 17 to a 7 because I don't feel like putting 17 tick marks in a graph. So make that a 7, okay? Now, go ahead and draw your coordinate plane. And here we go. Now remember, students, what I taught you. Input, see the word input? Input is the same thing as x values. So these are your x values right here, okay? Output is the same thing as your y value, okay? And that's why I taught you all of this. Very important you see this, okay? So, all of these right here are your y values. So, you have an ordered pair of 1. When you put in 1, it gives you out 1. So 1 comma 1. Next, negative 1 gave you out a 1. So negative 1 comma 1. 0 gave you out negative 1. So 0 comma negative 1. Negative 3 gave you out 7. So negative 3 comma 7. And then 3 gave you out 7 also. So 3 comma 7 too. So do you understand? Now I took my inputs and my outputs and I wrote them as ordered pairs. It's very important that you see that, okay? Now plot those points and you're finished. 1, 1, over 1, up 1. Negative 1, 1, negative 1, positive 1. 0, negative 1, 0, negative 1. Negative 3, 7. Negative 1. Or no, negative 3, 7. Positive 3, 7. So positive 3, 7. You do not connect the dots. You do not draw a graph. When they say sketch a graph, they're simply saying to you to plot the points. So what we're doing now is we're simply taking your inputs and your outputs. In the last problem, we were taking ordered pairs and learning how to interpret them as domain or range. Now, I'm giving you a mapping diagram, inputs and outputs, and you're learning how to write them as ordered pairs and then plot them. Really not difficult, okay? Not like we did before. You can watch me do this problem here, or you can do it on your own. That's totally your decision, okay? But I'm giving you a mapping diagram here, alright? And I want you to take this mapping diagram, and I want you to plot it or graph it on a coordinate plane, okay? And by the way, let me say this. Everybody listen. You do not have to list out these ordered pairs if you don't need to. If you can look at this problem here and realize that 1 gives you out 2, so you're at 1, 2, and put a point there. I have no problem with that. For me as a teacher, I'm going to go ahead and list all of these out so students can see what I'm doing, okay? So, in fact, that's one thing about a video class, guys. If you're really getting this and you want to move a little faster and you want to pause this, work this problem out, and then fast forward to the end of the problem, see if you got it right. Feel free to do that, okay? You can sometimes speed these up or slow them down, whatever you need. Alright? Okay, here we go. So, My first ordered pair is 1, 2. But don't miss that 1 also gave you out negative 2. That's another ordered pair because the number 1 right here had 2 arrows coming off of it. 3 has 1 arrow coming off of it, so 1 ordered pair. 3, 0. Now negative 5 has 2 arrows coming off of it. So negative 5, comma, 4. Negative 5, 4, and negative 5, negative 4. And here we go. We're good. Let's go ahead and plot these points, alright? 1, 2, over 1, up 2. 1, negative 2. So positive 1, negative 2. 3, 0, over 3, up and down 0. Negative 5, 4. 1, 2, 3, 4, 5. Negative 5, 4. And negative 5, negative 4 right here. There we go. Okay, and that's it. So once again, we're practicing taking inputs and outputs and plotting them on a coordinate plane. Not too difficult at all. Okay, students. All right, moving on. Now, what if I gave you a graph and asked you to describe it, okay, by using either a table or a table of values or a mapping diagram? Could you do that? Let's try. I want to give you a graph and I want to ask you to describe it by using a table of values or a mapping diagram, okay? So here we go. I'm giving you this graph here, so copy that down, please. Well, students, it really doesn't matter which one you do first. I'm going to start off doing a table of values, okay? So if I asked you to write this graph or describing it by using a table of values, here we go. It's not that hard to do, I don't think. How many ordered pairs do we have? 3, 4, 5, 6. There we go. Now this ordered pair here. Well, guys, we know this ordered pair is to the left or to the right 0, and it's up 4. So that ordered pair is 0, 4. This ordered pair is over right to the 2, and it's up 3. So 2, comma 3. This ordered pair is over to the right 4, and it's up 1. So 4, comma 1. This ordered pair is 4 to the right and down 1. So 4, negative 1. This ordered pair here is over 2, and it's down 3. So 2 to the right, positive 2, down 3. This ordered pair here is not to the right or to the left. It's right in the middle, so 0, and it's down 4, so negative 4. And there we go. Okay, so guys, that's really simple. We just took a graph and we described it by using a table of values. Now, let's describe this graph using a mapping diagram. Okay, so here we go. Let's take this graph and let's draw or write a mapping diagram. So here we go. Call this our input and our output. Okay, now 0, 4. So put a 0 here and a 4 here, and then draw your arrow. 2, 3. Put a 2 here and a 3 here, and draw your arrow. 4, 1. Put a 4 here. Draw your arrow and put a 1. Now, here's where it gets a little tricky. You have 4 again. Don't draw another 4, okay? 4, when you put in 4, you got out 1, but when you put in 4, you also got out negative 1. So put a negative 1 here, and then draw another arrow from 4. There we go. So 4 has 2 arrows coming off of it. Look at your next ordered pair. 2, negative 3. Well, 2's already here, is it not? Right here's 2. Put a negative 3 over here, and then draw your line from 2 to negative 3. then 0, -4. Well, students, 0's already here. Just put a -4 right here. And if you have to get creative and do something like this, I have no problem with that whatsoever. Okay, there we go. So 0, 0 had two outputs, 2 has two outputs, and 4 has two outputs. Okay, so there we go. Pretty simple. Alright, hope that makes sense. Now moving on. By the way, let's go back a page and look at that graph. Does that graph represent a function? Well, let's go all the way back to our very first page. We had a definition of a function. Let's go all the way back here. And let's see if we can't drag that down here a little bit so we can use it. Alright, there we go. Now, at the very beginning of the class period, I think, let me pause and say this, students. I think everything I've showed you so far has been pretty simple. X values, input, independent variable, domain, all of those four words can be used the same. Y value, output, range, dependent variable, all of those can be used together interchangeably. Okay, that's been pretty simple so far. This will be a little difficult to understand, but I think you can get this. Okay, you have a function when each input has exactly what? One output. So we're going to go back to this graph. We're going to examine it. Okay, does this graph represent a function? Well, there's two ways to do this. Draw a mapping diagram like this. If there is just, listen, if there is just one time that your definition fails, then it's not a function. Just one time. It only takes one contradiction for this to not be a function. Now the definition says each input has to have exactly one output. Well, this totally fails. This 0 has how many arrows coming off of it? 2. That means 0. Your inputs are right here. Here's your inputs right here. These are your inputs right here. The definition says each input must have exactly one output, not 0, not 2, not 3, 1. So 0 has 2 arrows coming off it. That's 2 outputs. 2 has 2 arrows coming off. That's 2 outputs. 4 has 2 arrows, 2 outputs. Now it only has to fail one time. So if the number 2 would have had 1 arrow and the number 4 would have had 1 arrow, this is still not a function because 0 has 2 arrows coming off of it. So this input here, 0, has 2 outputs, 4 and -4. So no, this is not a function. Now, there's another way to look at this too. I'm going to show you a really cool shortcut, okay? Watch this. Anytime you're trying to evaluate a graph and decide whether or not it's a function, if there is one point directly above or below another point, then you can immediately stop and know that it's not. This graph is not representative of a function. And here's how you know that. Anytime two ordered pairs fall right directly above or below each other, that means they're going to have the same x value, 0 and 0, but they're going to have two different y values, 4 and -4. That's why 0 has 2 arrows coming off of it. It only has to happen one time. If it happens once, then you know you don't have a function. Look at this here. It happens again right here. I have 2 more points that are directly above and or below each other. That's why 2 has 2 arrows coming off of it. See these 2 ordered pairs here? They're directly above and below each other. Well, that's why 4 has 2 arrows coming off of it, okay? So if I ask you if a graph is a function or not, you can do one of 2 things. You can draw a mapping diagram and then look and see if any of the numbers have 2 arrows coming off them, or you can just look and see if there are any points that are directly above or below another point. If that happens just one time, then you do not have a function. Okay? Hope that makes sense. Now, in fact, let's go back into your notes and look at all the things we've done so far. Let's see if they represent functions, okay? represent a function? Right here. Well, no, because look, right away you see 1 has how many outputs? 2. 3 only has 1 output, it has 1 arrow coming off of it. Negative 5 has 2 arrows coming off of it. Negative 5 is negative 5 has 2 outputs. Look, guys, you cannot have any inputs that have more than 1 output. You cannot do it, okay? Let's go back and look at some more. How about this one here? You should find this one in your notes. This one here is great. This definitely represents a function. Look, how many arrows are coming off the 1? Well, let's go back real quick. Did you notice in this graph here, there were points directly above or below each other? See that? That's another reason this is not a function. You should make note of that in your notes. Notice in this problem here, there are no points directly above or below each other. Okay? And plus, look at each input. Each input has 1 arrow coming off of it. Okay? So yes, this definitely represents a function. Definitely, yes. Alright, let's go back some more and look at some others that we've looked at. How about this one here? Would this represent a function? Well, probably the best way to do this is to quickly draw a mapping diagram. 0, 1, negative 1, negative 2, 2. And then these are your inputs over here, and these are your outputs over here. 0 gave you out a negative 1, 1 gave you out a 2, negative 1 gave you out a 0, negative 2 gave you out a 5, 2 gave you out a 9. Each input has 1 arrow coming off of it. So yes, this is definitely a function. Each input has exactly 1 output. So yes, these ordered pairs here would represent a function. Now these ordered pairs here, they would not represent a function. Okay? And there's 2 ways to know that. You can do a mapping diagram where you can see, you can look at the x values. And notice you've got some repeat x values right here. 4 gave you out a 3, and 4 also gave you out a negative 3. So if you were to do a mapping diagram, you would have a 4 right here, and over here you would have what? 3 and negative 3. Do you see that? 4 comma 3, 4 comma negative 3. So this input right here has how many arrows coming off of it? 2. And so that means you have 2 outputs. So this input has 2 outputs. It only has to happen once. Okay? Now, if you want to, you can do it the longer way. You can make a really big mapping diagram and do all of the numbers. List all of your x values. Negative 1/2, 4, 0, and then draw arrows to your y values. You can do that, okay? No problem. 4 gives you out a 3. 4 gives you out a negative 3. 0 gives you out a 1. 0 also gives you out a negative 1. Okay? So that's totally fine to do. You can see right away this input has exactly 1 arrow, 1 output. That's good, but this one has 2 arrows. This one has 2 arrows here. So no, this is not a function. No. No function, okay? Because each input did not have exactly 1 output. Let's see if there's some more. That might be it. That's it, yeah, okay. Alright, so let's go back down here and finish this up today. So, alright, now, let's continue on. Let's wrap this video up by learning what function notation looks like and how to evaluate a function at a given number. I'm going to give you 3 numbers, or 3 problems. Please take really good notes. So let's take a look at our first problem, students. There it is. Oops, sorry about that. And there we go. Now, copy that down. We need to talk about this a lot. Okay? So please take really good notes. First of all, we call this function f. Okay? Write that down. This is our f function because it says f right here. How do you pronounce this? That is not f times x. It is pronounced f of x. Please learn to say that correctly. F of x equals, got it? This function here say that f is a function of x. Write that down, please. Now what that means is your f function is based on x, because x is what you have over here. If you had a y right here, then we would call this f of y. Got it? If we had a z right here, if this was a z, then we would say f of z. Okay? So what this notation means is simply this. We call it our f function. We pronounce it f of x, and it means f is a function of x, or f is based on x. Now, let's evaluate. When you see f of -1, that means we're evaluating the function f at what value? -1. It does not mean you're putting -1 in for f. It means you're evaluating the f function right here at f of -1. Okay, so here's what we do. Watch carefully, please. We put f of -1. So instead of saying f of x, we say f of -1 equals. Now, wherever there's an x, we're going to put -1. So here's a negative sign, bring it down. Here's an x, put parentheses and put -1, then square it, then bring down your +3. Now, you do not multiply these two first. Do not do that. You first square -1. So you bring down your negative sign, and then you square -1. -1 times -1 is a +1. So a negative +1 is -1. Then bring down your +3. So you square -1. Negative times negative is positive. Bring down the negative sign. Negative positive is negative. Combine those two. You owe me $1. You have 3. You pay off your debt. You have 2 left over. So here's how you write your final answer. F of -1 equals 2. Now, a lot of students get to this step here, and they think they have to divide both sides by -1. If I had $1 every time a student did that, I could retire. Students do that all the time. Cross these off, and then put f equals -2. Guys, I told you at the very beginning, this f parentheses x does not mean multiply. It does not, okay? It's just function notation. It's a way to write a function. It means f of x. It means f is a function of x, or f is based on x. Okay? So when you get all done here, that's as far as you go. Now, if I asked you to write this as an ordered pair, you would then put -1, 2. Doesn't that make sense? What did you put into the equation? -1. What did you get out when you did that? 2. Input, output, x, y, input, output. You put in a -2. You got out a +2. Okay? So you would pronounce your final answer. You would say f of -1 equals 2. F of -1 equals 2. Alright? Or you can write it like an ordered pair. Let's try 2 more of these. Alright, sometimes that should be a G right here. Sometimes functions are written as G. Okay? So we call this a G function, and we pronounce it G of x. G of x. And notice I want you to evaluate it at G of 4. That means I'm going to substitute 4 in for x. So G of 4. That means I'm putting 4 in for x. That means I'm evaluating the function at 4. G of 4 equals 3 parentheses. Here's your x. 4, and then squared, then a negative sign, then x. I'm going to put 4, and then -1. Alright, now, do not multiply your 3 and your 4 first, okay? You first square the 4. So I have 3 times 16, because 4 times 4 is 16. So then I have 3 times 16 is 48. negative times a, positive 4 is negative 4, and then negative 1. Okay? So if we simplify all this, we would get 43. So g of 4 equals 43. So here's what that means. It means the function g at the value of 4 equals 43. Or g of 4 equals 43. Or you could look at it like this. An ordered pair. You put in 43, excuse me. You put in 4, that's your input. And you got out 43, that's your output. Okay? Input, output. Alright, one more. Why don't you pause this one, try it on your own, then restart the video, students. It's up to you. You can do it with me or pause the video and try it on your own. Just be careful doing the fractions, so be careful. Okay, here we go. Either you've already done this and you're checking it or you're doing it with me. We're going to evaluate the h function. And by the way, those are your three. The three most common letters used for functions are f, g, and h. F of x, g of x, and h of x. There are others, but those are the most common ones, okay? So, we're going to evaluate this h function at h of 1/2. So, h evaluated at 1/2 equals negative sign, then x, so parentheses, then squared, then positive 4, then parentheses, 1/2, and then positive 3. Okay, we square the 1/2 first of all, so 1/2 times 1/2 is 1/4. Positive 1/4, then bring down your negative sign, okay? So we square the 1/2 first. 1/2 times 1/2 is 1/4. Bring down the negative sign. Negative positive is negative 1/4. 4 times 1/2 is positive 2, and then positive 3. Now if you combine this, you'll get negative 1/4, and then a positive 5, positive 2, and positive 3. And then 5 minus a fourth would be 4 and 3/4. Okay? So you would say h of 1/2 equals 4 and 3/4. Or you could say h evaluated at 1/2 equals 4 and 3/4. Or you could say you have